Today's lesson is a continuation on 3.2. We're going to do three more proofs and then solve them with triangles congruent, same side, angle, side, 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 or angle, side, angle. Okay, again, ASS will not work. So far we have given that BC bisects AD. Okay, so we have BC bisecting AD. Now, knowing that it bisects AD, we have these two segments congruent, AE and ED. So go ahead and write that down. Because it bisects AD, I know AE is congruent to segment ED. Now that's going to be my first side of the triangle. I also have angle 1 is congruent to angle 6. So this is one that's outside the triangle. Okay, that cannot be my second angle here because it's not an angle inside the triangle that I want to prove. So I'm going to pull something from the diagram. From the diagram, I can say 1 and 2 are supplementary and 5 and 6 are supplementary. Now, why are they supplementary? Remember, they have to be adjacent and they have to make up a straight angle. 1 and 2 are adjacent and they also make up this straight angle. So go ahead and write that down. Okay, again, knowing that 1 and 2 are adjacent and AED is a straight angle, I can say angle 1 and angle 2 are supplementary. I can do the same exact thing for 5 and 6. Go ahead and write that down. Okay, so now I know that angle 5 and angle 6 are supplementary. Okay, so we have two sups. I'm going to now use my given. Angle 1 is congruent to angle 6. Okay, and if I have 1 and 1 and 6 and 6, I can go ahead and sort of cancel them out. 1 and 1, 6 and 6. What's left is 2 and 5. So 2 and angle 5 are now congruent. That is an angle inside the triangle that I want. And that's my second A. So angle 2 is now congruent to angle 5. Okay, and there's my A. Okay, so I can do angle side angle. So can I pull an angle up in front? Looking at the picture, this picture is kind of like a bow tie. So I can pull vertical angles out of here. Angle 3 and angle 4 will be congruent. Okay, because they are vertical. So angle 3 is congruent to angle 4. And that's my other angle. Now I have angle side angle. I'm going to group these three together and now say the triangles are congruent to each other. Triangle ABE is congruent to triangle DCE. Okay, go ahead and put your reasons down. I'm going to say this is 1, even though we did it last. 2, these are the same reason here. 1 here and the last one here. So my first reason, how do I know that angle 3 and angle 4 are vertical? That's because vertical angles are congruent. So I'm going to say all vertical angles congruent. Step 2, BC bisects AD. This is a definition of a bisector. It's a segment bisector because AD is a segment. Step 3, how do I know that adjacent angles and the straight angle are supplementary? Because if adjacent form a straight, then supplementary. Okay, step 4, you have to use this word supplementary in here. There's two sups. So we're going to say sups of congruent angles are congruent. And last but not least, how do I know the two triangles are congruent? For angle side angle. And I'm done. Alright, next problem. We want to prove AFE. So I'm going to go ahead and highlight the triangles that I want. AFE and DCB. Okay. This should ring a bell for you. We have midpoint, midpoint, and a segment. Okay, this is going to be either like divisions or like multiples. Anytime you see this, you have to remember that's going to be like divisions or like multiples. So go ahead and write that down. Okay, so they're giving me AC is congruent to DF. Okay, that's actually not a side of my triangle, so cannot say this is our first S. This is an entire side. Okay, and I also know B is a midpoint and E is a midpoint. So what they're doing is we're dividing it up, and now I can say this side, CB, is congruent to EF. So CB is congruent to EF. Okay, and that's either going to be like divisions or like multiples. Okay, remember if I'm going big to small, it's like divisions, small to big, it's like multiples. AC is a bigger side, and CB is a smaller side. So we're going big to small, that is like divisions. Okay, so this is my first S. I also have AF is congruent to DC. So I'm going to say AF is congruent to DC. AF is a side of my triangle, and so is CD, so that's okay. Okay, now I have this, and I have the two sides. Okay, this is my S. Okay, remember SSA or ASS doesn't work, so I'm going to squeeze in angle C. That is an angle inside the triangle, and angle F. That will work. Angle C is congruent to angle F. And it looks like that's my A. So it's side, angle, side. I can go ahead and group these three and say that the two triangles are congruent to each other. Alright, so my first one I talked about already. I'm going big to small, so we're getting smaller, we're dividing it. This is like divisions. And step two, side, angle, side, and I'm done. Alright, last problem. I want to prove that these triangles are congruent AFC. So I'm going to highlight that. AFC. So AFC and the other one, let's do blue, is DEB. So this one right here, they're overlapping each other. Okay, but make sure I get sides or angles of these two triangles. Anything else will not work. The first segment they're giving me is AB is congruent to DC. So let's go ahead and write that down. Okay, so this is AB is congruent to DC. That's actually not a side of the entire triangle, it's part of it. But in order to get the whole side, I need BD and AC. So ask yourself, how can I get that? Well, I have to add something to it. What do I have to add? I have to add this segment BC. If I added BC into AB, I'd get AC, which is the side of the triangle. And if I add BC to B to CD, I get this side BD. So I have to state that BC is congruent to itself, because that's what I'm adding. And then when I add them two together, I get AC is congruent to BD. Okay, now this is the side of the triangle. They're also giving me that FC is congruent to EB. Is that going to be a side? FC and EB, yes it is. It's the side of the triangle. I can go ahead and write that down. And they also give me that ED is congruent to FA. So we have this side ED and we have this side FA. Okay, that will also work. So this is the side of the triangle and so is this. We can group all three because now we have side, side, side. That will work. Triangle AFC is congruent to triangle DEB. Let's go back and label. Looks like this is 1, 2, and last but not least, 3. Go ahead and write your steps out right here. Pause it if you just want to try on your own. Okay, step 1 is reflexive. When something equals itself, we can say that we're using the reflexive property. Step 2, we're going from two smaller segments to a larger one, so I'm using addition here. Okay, the reason why I'm not using like divisions or like multiples is because it does not say midpoint, midpoint like it did in the first example. If it says bisects, bisects, or trisects, trisects, or uses a midpoint, then we have to use like divisions or like multiples. If they're giving us two segments that are congruent, we're either going to use addition or subtraction. Here we're using addition because we have, again, small segments, and we're getting a larger segment here. We're going small to big or small to a larger segment. And last is side, side, side. And that's it. We're done for today.